Modernage MCQs, Physics, first year, unit number 6, Fluid Dynamics, part 5. When airbag on arm is inflated, the blood vessel is compressed, radius is reduced, and blood pressure, option A, decreases, option B, remains same, option C, increases, option D, becomes 0. The key is decreases. Therefore, the correct option is A. Reason. For equation of continuity, A into V is equal to constant, where A is the area of cross-section, V is the speed, R. Speed is inversely proportional to area of cross-section. As area of cross-section A decreases, the velocity V increases, and corresponding pressure P decreases according to Bernoulli's equation. P plus 1 by 2 rho V square is equal to constant. As V decreases, P increases, therefore the sum remains constant. Hence, for inflated air bag, the blood pressure in vessels decreases. When air bag on arm is inflated, the blood vessel is compressed, radius is reduced, and blood velocity, option A, decreases, option B, remains same, option C, increases, option D, becomes 0. The key is increases. Therefore, the correct option is C. Reason. From equation of continuity, the product of area of cross-section and velocity is equal to constant. R, velocity, is inversely proportional to the area of cross-section. As area of cross-section A of blood vessel decreases, the velocity V of the blood in the vessel increases. Hence, for inflated air bag, the blood velocity in the vessels increases. Bernoulli derived equation for the flow of an ideal fluid from conservation of option A, mass, option B, volume, option C, pressure, option D, energy. The key is energy. Therefore, the correct option is D. Reason. The work done in flow of fluid is due to the change in kinetic energy as well as the change in potential energy. Delta W is equal to delta K plus delta U, where delta W is the work done, delta K is the change in kinetic energy, delta U is the change in the potential energy, which is the conservation of energy. The relation delta W is equal to delta K plus delta U is used in the derivation of Bernoulli's equation. Hence, Bernoulli's derived equation for the flow of an ideal fluid from conservation of energy. The speed of air at the top of an airplane wing is V1 and at the bottom is V2. For aerodynamic lift, option A, V1 is greater than V2, option B, V1 less than V2, option C, V1 is equal to V2, option D, V1 is equal to 0. The key is V1 is greater than V2. Therefore, the correct option is A. Reason. According to Bernoulli's equation, P1 plus 1 by 2 rho V1 square is equal to P2 plus 1 by 2 rho V2 square, where P1 is the pressure at the top, P2 is the pressure below the wings, V1 is the speed at the top, and V2 is the speed below the wings. Rho is the density of air. For P1 greater than V2, P1 is less than P2. Therefore, aerodynamic lift is P is equal to P2 minus P1, or P divided by A is equal to P2 divided by A minus P1 divided by A. We have divided the equation by the area of the wings throughout. Therefore, it is the definition of the force P divided by A. So airlift is a force. F for lift is equal to F2 minus F1. Hence, for aerodynamic lift, V1 should be greater than V2. If an aerodynamic lift is F lift equal to F2 minus F1, then A, V1 is greater than V2. Option B, V1 is less than V2. Option C, V1 is equal to V2. Option D, V1 is equal to 0. The key is V1 is greater than V2. Therefore, the correct option is A. Reason: the aerodynamic lift is equal to F2 minus F1, or P divided by A is equal to P2 divided by A minus P1 divided by A, or P is equal to P2 minus P1. Therefore, P1 is less than P2. Indicates V1 is greater than V2 according to Bernoulli's equation. P1 plus 1 by 2 rho V1 square is equal to P2 plus 1 by 2 rho V2 square. Hence, for aerodynamic lift, F for lift is equal to F2 minus F1. V1 is greater than V2. The decrease in pressure with increase in speed of natural gas in a horizontal uniform pipe is explained by option A, Bernoulli's equation, option B, Torricelli's theorem, option C, viscosity of gas, option D, density of gas. The key is Bernoulli's equation. The correct option is A. Reason: the Bernoulli's equation for fluid flow in a horizontal pipe is P plus 1 by 2 rho V square is equal to constant, where P is the pressure, rho is the density of the gas, V is the velocity of the gas. The pressure decreases with the increase in speed of the fluid, so that the sum of pressure and kinetic energy per unit volume should remain constant. Hence, the decrease in pressure with the increase in speed is explained by Bernoulli's equation. When water is pumped from a well, 2700 Newton force is exerted on the piston of 9 square centimeter area. What will be the pressure on the piston exerted by the water? Option A, 9 into 10 power 6 Newton per square meter. Option B, 3 into 10 power 6 Newton per square meter. Option C, 2.9 into 10 power 6 Newton per square meter. Option D, 2.7 into 10 power 6 Newton per square meter. The key is 3 into 10 power 6 Newton per square meter. Therefore, the correct option is B. Reason: from the formula, P is equal to F divided by A, where P is the pressure, F is the force, and A is the area. We have P is equal to 2700 divided by 9 into 10 power minus 4, or P is equal to 3 into 10 power 6 Newton per square meter. Hence, the pressure exerted by the water on the piston is 3 into 10 power 6 Newton per square meter. In raising the water to a tank, a force of 3600 Newton is exerted by a pump on the piston of 12 square centimeter area. What will be the pressure in Newton per square centimeter on the piston exerted by the water? Option A, 3600, option B, 1200, option C, 900, option D, 300. The key is 300. Therefore, the correct option is D. Reason: From the formula P is equal to F divided by A, we have P is equal to 3600 divided by 12, or P is equal to 300 Newton per square centimeter. Hence, the pressure exerted by the water on the piston is 300 Newton per square centimeter. A rain droplet of radius 10 power minus 4 centimeter is falling with terminal velocity which is of the order of option A 1 micrometer per second, option B 1 nanometer per second, option C 1 picometer per second, option D 1 femtometers per second. The key is 1 picometer per second. Therefore, the correct option is C. Reason: from the formula of terminal velocity Vt is equal to 2 rho gr square divided by 9 eta, the terminal velocity Vt is proportional to r square because rho is constant, g is constant, eta is constant. The radius in centimeter is 10 power minus 4 and in meter is 10 power minus 6. The square of radius in meter is r square is equal to 10 power minus 12, which is the square of 10 power minus 6, which is equal to 1 picometer because 10 power minus 12 is pico. Hence, the terminal velocity of a rain droplet is of the order of 1 picometer per second. Two spherical drops of radii 1 millimeter and 2 millimeter are falling with terminal velocities in the ratio of option A 4 to 1, option B 1 to 4, option C 4 to 3, option D 3 to 4. The key is 1 to 4. Therefore, the correct option is B. Reason: from the formula Vt is equal to 2 rho g r square divided by 9 eta, the terminal velocity Vt is proportional to r square. Therefore, the ratio is Vt divided by V prime t equal to r1 square divided by r2 square, which is equal to 1 by 4, or Vt to V prime t is equal to 1 to 4. Hence, they fall with terminal velocities in the ratio of 1 to 4. A 2.5 meter tall tank full of water has 4 identical small holes at depths 1.7 meter, 1.4 meters, 0.8 meters and 0.4 meter. The speed of a flux is maximum from a hole at a depth of option A 0.4 meter, option B 0.8 meter, option C 1.4 meter, option D 1.7 meter. The key is 1.7 meter. Therefore, the correct option is D. Reason: the speed of reflex is Ve is equal to 2 gh under root, where h is the depth of a hole. The maximum speed of reflex is for maximum depth, which is 1.7 meter. Hence, the maximum speed of reflex is for a depth of 1.7 meter.